So this is the last lesson for this 3.5, and this is over graphing absolute values. Now, the thing with this is that it actually is very, I mean, it's the same thing we've always done. We graphed absolute values the other day, where we used transformations, moved things up, down, left, right, did stretches and compressions, did reflections. So it's really similar to that, and it's not anything, I guess I should say, it's not like we were doing it wrong before. With absolute values, there's a couple shortcuts we can do. Shortcuts to do, but also to get a little bit specific and have kind of a broader range of absolute values that we can graph. So let's go and get started just with this really quick review. Pluses inside your parentheses or your absolute value or your square root. That means you go to the left 3. 6 means down 6. Number 2, inside parentheses, that means you go to the right 2. Then outside your parentheses, your multiplying is a vertical stretch by a factor of 3. So all that stuff is still the exact same. None of that stuff actually changes. Again, we're just going to do it so we can be a little bit more detailed and a little bit more exact with these absolute value graphs. So a couple vocab things we need to know before we go on is the vertex. The vertex is the corner of the absolute value. It's the turning point. Now, that is not an actual mathematical definition. I don't know what the actual mathematical definition is, but it's probably complicated and has things that don't make sense or don't seem like they make sense. So I made that one because I think that's the easiest way to think of it. So it's the corner. So if you have an absolute value, it's a V shape. Well, that corner where you turn around or where you bounce off, that is your vertex. Now, your vertex is always an ordered pair. Every single time you have a vertex, you end up with an ordered pair. The other thing we're going to talk about a little bit, we won't use it a ton, or we won't have to use it a ton, but it's the axis of symmetry. The axis of symmetry is a vertical line that is the in the absolute value that everything reflects across. So what I mean by that, if you look at the same V shape, your axis of symmetry is a vertical line that goes right to the vertex. And what it means is if you have a point on this side of that axis of symmetry and it's on your function, if I reflect that across, you'll have another point on the other side of that that's reflected on your function. The axis of symmetry. Now, here's the key with the axis of symmetry. First off, it's a vertical line. X is equal to a number every single time, no matter what. But it's always going to be X is equal to the X value of your vertex. And that makes sense if you think about it, because the X value of your vertex is going left and right. And so if you can imagine, if your vertex is at 3, 5, that means I go over to the right 3 and up 5. If you put a vertical line through that, it's going to go right through 3. Any sense? Again, if you just think, if you just memorize, it's always X is equal to whatever that X value is. So for my example, it would have been a 3. We'll talk about that more in a little bit. So is this in vertex form? So this y is equal to c, absolute value x minus h plus k. It should be very familiar. It's the same form we've done in all these. The only difference is, again, I'm going to kind of describe it a little bit differently. So instead of saying left and right and up and down, which is correct, now I'm going to say my vertex is the opposite of h and k. There's a couple other ways to look at it, but I think that's the easiest way. So whatever the h is the opposite of that, the k. Now that makes sense because it has a minus, you go to the right. Well, if we go to the right, then that's why it's a plus. That's why that h is a plus. So that's your vertex, the hk. Then just like we said, the if you want to use that formula, it's the opposite of h, or it's the x value of your vertex. I always find my vertex first, and then I get my axis of symmetry for this problem. For parabolas, it's a little bit different. We'll talk about it. Now, that C in front does not affect your vertex at all. That c that's in front, it could be a million, it could be -10, it could be 1. It's not going to affect your vertex at all. What it is the slope. Put in parentheses is because if you have absolute value, slope on this side is not the same as on this side. So when I say it's the slope, I put it in quotes because it's not technically the slope. I guess technically it's the slope of one side, but that's a good way to look at it, and most people are okay with that. Last but not least, if that c is negative, that's where it's reflected across the x-axis, and if it's reflected across the x-axis, it just opens down. Now the good news, in my opinion, is the slope and that negative work together when you graph yours, and you'll see what I talk about or what I mean in a second. So, moving on. The first one, all we're doing is giving the vertex and the axis of symmetry. Don't make this like opposite of this number, so -3 and -6. Now, if you think about it, that makes sense because to the left. So if you take your ordered pair to the left 3, you are subtracting 3. Stop bouncing the ball or I'll throw it away. It's okay. Vertex. Now the axis of symmetry, the vertex is x is equal to, and then you just put your axis of symmetry in there. X is equal to -3, or sorry, the x value of your vertex in there. So -3, your x is equal to -3. Again, it is not an accident that those are the exact same numbers. They will be that every single time. Next one, the vertex is +4, +10. Again, it's the opposite of what's inside. The outside is the same. And again, it makes sense because the outside goes up and down normal. So I have x is equal to +4. And the next one, number 5. Now again, this 2 in front doesn't affect your vertex at all. There is no numbers inside your absolute value. So the x value of your vertex is just 0. You don't go left or right at all. So the x value is just 0. Then it goes down 8. Axis of symmetry is just x is equal to 0. Don't make that harder than it is. Go ahead and do number 6 and 7 on your own. I'll give you guys about a minute to do that, and then I'll go ahead and put the answers up, and we'll move on. So number 6, you should get -5, -3. X is equal to -5. That's your axis of symmetry. And number 7, we have +6 and then 0. It doesn't go up or down at all, so it's just 0. The axis of symmetry is x is equal to 6. Again, every time the axis of symmetry is always that x coordinate of your vertex. So now we're getting into the graphing, and this is the biggest part of this, is the graphing part. And there's 2 different ways to look at it. They're really the exact same way. One way to look at it is find your vertex right away. So just like we're doing, my vertex is -1, 0. So that's right. Obviously, if you want to do it that way, you can. I don't do it that way because I like to use the transformations that we've been using, because those transformations we've done since the very beginning of this chapter. So we've done it for about 2 weeks now. So what I mean by that is I know that this is to the left 1. So I start at 0, 0. I go to the left 1. That's where my new vertex is. Once you have that new vertex, again, it used to be where this was a vertical compression, but now that is our slope. Now again, for every other pair function we have, it's still a vertical compression. If I told you to describe the transformation, you would still say it's a vertical compression, and you would not say it's the slope. But when you're graphing this, that counts. It's the slope. So you go up 2 over 1, 2, 3, up 2 over 1, 2, 3. Now again, the left-hand side is reflected across that axis of symmetry. So the other way to look at it is if you go up 2 over 3 to the right, the other side is up 2, it's just over 3 to the left. 1, 2, 3, 2, 3. I mean, to call that the slope because technically, I guess it's the slope for part of your graph, but for the other part of your graph, it's not really. But again, I still am going to call the slope because I think that helps students. But just remember, that's only the slope for your right-hand side. To find your left-hand side, you have to either I guess to find the left-hand side, you just have to remember it works as a V. So it's reflected. Number 9, again, if you want to find your vertex, you can. For me, I just know this means we're going down 4 and we're not going left or right any, so that's what I do. Again, it's literally pretty much the same way to do it, just different ways to say it. And then my slope. Now, again, this is a negative, so already I know that it opens downward. But the way I like to do it is I like to keep that in my slope. When I keep it, when I do my slope, I keep that in mind. So I go down 2 over 1, just like if I had -2 as a slope for a line. Down 2 over 1, and then reflected down 2, 1 to the left, down 2, 1 to the left. So that is your graph for this one. Actually, you need to know that opens down if you incorporate that into your slope. Number 2, again, if you want to vertex is -4, -3, so you go -4, -3, that's fine. But again, I still look at it as left 4, down 3. My vertex. My slope is negative, so it's -1. So down 1 over 1, down 1 over 1, and then down 1 over 1 to the left. You reflect those to get your other shape, or to get your other side, to make it the shape of a V. And number 11, go to the left 2 and up 1. Graph, my slope is 3 over 1, 2, 3 over 1, 2. 1, 2, 3 over 2. Taking the other side, up 3 over 2 to the left, up 3 over 2 to the left. Graph. Now again, that's a lot more accurate than we could have done before, because before that would end up, actually that's a stretch. A lot of people think it's a compression because it's a fraction, but 3 over 2 is bigger than 1. It's 1.5. So doing it this way with absolute values does make it a little bit more accurate. Again, keep in mind though, this is only with absolute values. You cannot do this trick with all the other problems. So go ahead, same thing, do number 12 and 13 on your own. I'll give you guys a second, then we'll go over those answers. All right, so my answers for 12 and 13 are up there. I went, for number 12, I went left 5 and down 2, but you can also say your vertex is -5 and -2. It's all the same. What we're using is 3, so up 3 to the right 1, up 3 to the right 1, and then reflected across is up 3 to the left 1 to make that V shape. Number 13, thing, I went to the right 3, up 2, then my slope is -1/2, so down 1 over 2 to the right, down 1 over 2 to the right, and then to reflect it, I did the other one, down 1, 2 to the left. Any questions on those? All right. So just to make sure we're solid with this, I also like to make sure we can do the other way around. It's a little bit more difficult, but it does help you kind of understand both ways. But writing the equation for this. Down, again, if it helps the vertex first and then plug that in, you can. I personally still like to do it the left, right, up, down way, because we've actually done this before, where we did it like that. But the other thing that I do before I start anything is I put the slope. So my vertex is here. My slope looks like I go through this line. So up 1 over 1, 2, 3. So up 1 over 3 is my slope. So I start with y is equal to, I know it's going to be 1 over 3. That's how we're starting. X, I went over, my vertex is over to the right 2. So remember that's -2. If you go to the right, it's minus. I go up or down a, so I don't. Again, you could set your vertexes at 2, 0, and then plug that in. Honestly, the only thing that concerns me with that is I think a lot of people are going to forget to take their opposite. I'm hoping that if I say you go to the right 2, I'm hoping remember that, because like I said, we've been doing that since we started chapter 3, knowing that whatever's inside the parentheses, it actually looks like it's opposite. So 15, same thing. I'm going to find my slope first, and it looks like it is -2 over 1. So I have y is equal to -2. Then I went to the left, 1, 2, 3, 4. So that's +4 since it's to the left. and then it went up 3. Again, if you want to sub in -4, 3 and do it that way with your vertex, you can. Doesn't make any difference. And the last one, number 16, it's going down 1 every time, so -1 over 1, just -1. So y is equal to negative. I went to the right 2, so that's x minus 2, and I didn't go up or down any. It's right on that axis still, so it just stays x minus 2. All right, the last two we'll do for you guys to do, and then we'll do the inequalities. So per usual, do these quick. I'll put the answers up here in a second. All right, so my 2 answers are up there. Again, for me, the biggest number is to find the slope, and I think it helps to do that first. I know some people that do that, they don't do that first. They do the vertex part first. That's fine if you have enough room, but I've seen some people have these things in there and stuff, so I think it's better just to go ahead and find your slope first. Then you can do, again, whether you're using vertex form or your transformations, you can. All right, last but not least, the inequalities. Now, again, we just got doing these with the other transformations, so it's really not anything different. Besides that, the graphs can be a little bit more particular or a little more accurate because we just learned how to do absolute values. But it's literally the same thing we've done all day today. The only difference is whether the line is dotted or solid, and if you're shading above or below. Everything else is the same. So -3 is your vertex. Up 2 over 1, 2, 3 to the right. Up 2 over 1, 2, 3 to the right. Then when you reflect those, you go up 2 over 3 to the left. And up 2 over 3 again. But then this is a dotted line. There's no line under it. Which, again, as usual, if you want to put it as a solid line and then label it dotted, that's fine. Above or below this, well, this is above. Now, if you have a really skinny graph and it's hard to tell which is above and which is below, just focus on your vertex. So, is it above or below your vertex? Well, if y is greater than, you shade above your vertex. Well, if you shade you shade that whole area. Whole area is everything inside your absolute value. I went up 3, then I went down 1 over 2, down 1 over 2, reflected, do the same on the other side. This is a solid line. And this one, y is greater than, again, that one is above. So when we talk about above, you talk about above that vertex, so that's right here. That means everything else in that same area, so everything outside. Now, I had somebody earlier today that looked at this one and said, how come on this one, when it was greater than, you shaded outside your absolute value? I told them that's not how you can look at it. Don't think of it as inside or outside. When you're initially graphing, it's either above or below. Those are the only two options. These are both greater than, so they were both above. Now, since above the vertex was outside, that's why one of them was outside. Above the vertex and the other one was inside, that's why we shaded inside. But there's not a good, quick, and easy way for me to tell you how to know whether it's inside or outside your absolute value, other than making sure it's above or below. Okay.